In this section, we're going to be simplifying rational expressions. Basically, you just factor if possible, and then cancel out the like factors. To find the excluded values in a rational expression, factor out the denominator if possible, set it equal to 0, and solve. The reason that they're called excluded values is because you know that no denominator can equal 0, or it's undefined. So when they ask for the excluded values, they're basically saying what values would you put into the variable in the denominator to make the denominator equal 0. So for instance, in number 1, the numerator doesn't even matter. When they're asking for the excluded values, you take the denominator, set it equal to 0, and solve for the variable. So when I do that, I get b equals -7. So b cannot equal -7 because if it did, that denominator would equal 0. So that's the answer for A. In B, you do the same thing. You set it not equal to 0 or equal to 0, either way. And then I'm going to factor this because it's a quadratic term. So I get A times A is A squared, and then -4 times a +3 would give me -12, and -4 plus 3 would give me a -1. So if I set each of those factors not equal to 0, I'll get my excluded values. So I get, if I added 4 to both sides, A cannot equal 4, and A cannot equal -3. So both of those are the excluded values. In C, you just take your denominator, set it not equal to 0, and subtract. So if I divide both sides by 2, I get x cannot equal -1/2. So basically that's it. Any excluded value, you just say what it cannot equal, because if it did, the denominator would equal 0. We're just simplifying monomials in this problem. So simplify 32x to the 5th y squared over 4x squared y to the 7th. This goes back to chapter 8 when we were simplifying monomials back there. So it's in this section in rational expressions because there's variables in the denominator. So let's just do this. 32 over 4 is 8 over 1. So I just simplified the fraction. I just simplified 32 over 4 to 8 over 1. Now I have 5 x's in the numerator and 2 in the denominator. So that means I have 3 more in the top than in the bottom. I have y2 over y to the 7th, which means I have 5 more y's in the denominator than in the numerator. Number 3, simplify 4x plus 16 over x squared minus 5x minus 36 and state the excluded values. So I am going to factor. So in the numerator, I can factor out a 4. That is my greatest common factor. So if I took out a 4, I'd be left with x plus 4. Because what do you multiply to 4 to get 4x? X. What do I multiply to 4 to get 16? 4. In the denominator, I'm going to factor this. So x times x is x squared. What multiplies together to give you -36? That adds together to give you a -5, a -9, and a +4. Okay, so before I simplify at all, I'm going to state my excluded values. You want to do this before you simplify, okay? So right here in the denominator, I have x minus 9 and x plus 4. I'm going to set both of those not equal to 0 and solve. So I get that x cannot equal 9 and x cannot equal -4. So those are my excluded values. Now, when I come back over to the problem and I simplify, I have an x plus 4 in the numerator and in the denominator. Those can cross each other out. So my final answer is 4 divided by x minus 9. So that is the problem simplified, and those are my excluded values. Number 4 says simplify 25 minus x squared over 8x minus 40 and state the excluded values of x. Well, this is something that you don't see very often, but you can. Do you see how the x squared is in the back of the 25? It's behind it. I don't like that. I want to put it in the front. So I could change this to negative x squared plus 25 over 8x minus 40. But then you've got a negative quadratic term. So what I'd like to do is I'd like to factor out a negative 1 and make this x squared minus 25 over 8x minus 40. Now the reason that I'm doing this is because I want my binomial to be in standard form, and now I have a difference of squares. So if I factor this as a difference of squares, what times what gives me x squared? X and x. And what multiplies together to give me 25? 5 and 5. One needs to be a positive and one needs to be a negative. Now, in the denominator, what's the greatest common factor of 8x and 40? 8. So if I factor 8 out, I'd be left with x minus 5. Now you can see that right here, I have the same binomial, okay? First of all, before I start crossing anything out, they ask for the excluded values. So I'm going to take the denominator, which was 8x minus 40, set that not equal to 0, and I would get 5. Now you can also see in this binomial right there, I could also do the same thing. And I would get the same answer. So really going back to the original problem is not necessary. You just want to make sure you do it before you cross anything out. Now that I have my excluded value, I want to simplify this. Okay, so I can do that by crossing out the x minus 5 because I have one in the top and one in the bottom. What would I be left with? I would be left with negative 1 times x plus 5 over 8. And that's my answer. Number 5 says find the zeros of the function f of x equals x squared plus 8x plus 7 over x plus 1. The zeros of the function is the same thing as just solving it or finding the solutions because those are the points that if we graph this, it would cross through the x-axis. So finding the zeros and find the solution is really asking the same thing. So we're going to factor. All right, so you would get f of x equals, let's factor the numerator. So what multiplies together to give us x squared? X times x. What multiplies together to give us 7? That adds together to give us 8. 7 and 1. And then in the denominator, we have the x plus 1. Okay, so we are going to cancel out. Now, if it asks what the excluded values are, we would know that's negative 1. But it's not asking us, so we're going to simplify by crossing out the x plus 1 in the numerator and the denominator, and we're left with f of x equals x plus 7. Now, we know that the zeros of the function is where the x-axis, where the graph crosses the x-axis, or where the y equals 0. So instead of f of x, I'm going to plug this in with 0. I'm going to substitute a 0. Because that's the zeros of the function, okay? This is where you would hit a 0 for y. So then solve for x. So subtract the 7. So we get x equals negative 7. So the 0 of the function would be negative 7. The last problem says simplify x squared minus 2x plus 1 over 5x squared minus 20x plus 15 and state the excluded values of x. All right, so I'm going to factor both numerator and denominator. In the numerator, what times what gives us x squared, x and x, what multiplies together to give us a positive 1 that adds together to give us a negative 2. Well, we know 1 and 1 are the only things that multiply together to give us 1. But how can they add together to give us a negative 2? We make both of them minus 1. Now in the denominator, I have 5x squared minus 20x plus 15. All of those can be factored by 5. So if I factor out a 5, I'm left with x squared minus 4x plus 3. Now I need to continue factoring that denominator. So I'm just going to rewrite the same thing in my numerator, x minus 1 times x minus 1. And in the denominator, I'm just going to leave that 5 there for now. What multiplies together to give me x squared, x and x? What multiplies together to give me a 3? Well, 3 and 1, but they have to add together to give me a negative 4. So both of these are going to be negative. So that's completely factored. The problem says state the excluded values. So my excluded values, I would set both factors in the denominator not equal to 0. And I would solve both of those. So I get x cannot equal 3 and x cannot equal 1. So those are the excluded values. Now to simplify, I can cross out one of the x minus 1's and I'm left with x minus 1 over 5 times x minus 3. And that is my final answer.